And I'm live. That is pretty cool. And this setup is also like pretty cool with the lighting and stuff. And yes, today is 10th of November 2025, Monday. And with that, let's begin. Okay, this is the thing that we will be doing. Differential, digital differential analyzer graphics algorithm. And the main thing in this is just 1 minute. Yep. So what is the problem that we are trying to solve here? And shit, I cannot access my terminal. First, I have to like enter this thing. 406, 46, 46 into 60, 2400 plus 360, 2760 minus 46, 2714. Should I? This might be, I don't know. Okay, shit. That is correct. Okay, cool. Okay. And yes, the problem that we have to solve, we must set game. Shit. Yes, 41. Um, so 960. Yeah, 960 plus 24, 984. Yeah, that just happens. And that is how my terminal works. Okay, so the problem that we are trying to solve here is this. Right now, this is game of life, and whenever I click and move my mouse over some cells, those cells are lighted. And the problem is the fetching function, which which gives the program the current location of the cursor, is fetching at it is fetching quickly, but the value of the cursor is not updating faster than 60 fps, which is the current fps for the screen rendering. So I looked around, and even if we were to write native fetch functions for fetching the current value, it will not give us more precision. It will not, no matter what kind of polling we do, we won't get enough precision to cover every cell that the mouse is passing over. So what we have to do here is digital differential analyzer, which I right now do not understand. I only understand like the high level concept, which is this. Let's say we got that the mouse was here and now the mouse is here. So it must have traveled this distance, right? And also we can get the time during which this thing was traveled. And then our goal would be, since this is a grid, our goal would be to find out through which cells the mouse went through and then light up all of those cells. And shit, that is going to require some maths, which is cool, which is cool. Yes, this is my like basic understanding of this thing, and let's read and we will refine this. And before adding this thing to the game, we will write some other function, some program to test this out. And I was watching a YouTube video in which a person had two circles, and one of them moves with the mouse with the cursor position, and the other one moves with the keyboard up and arrow keys. And on the screen there is always a line between those 2 points. So let's try to build something like that, and that would be nice. Yo, hello. And yeah, let's do that. Programming stuff, Raylib, and yeah, Raylib, make the DDA, digital differential analyzer, and main.cpp, right? And include. Really have h. That does work. Int main, and we give a const in height, let's say 800, and const in width is also 800, and then init window with width first, and then the height, and then the title, which will be uh, digital differential analyzer. Cool. So our window will be there on the screen, and yeah, our window will be there on screen, and we do not want anything else. We just want two circles to be there on the screen. Let's see how to make circles on the screen. We can just go to the cheat sheet and see circle. Yeah, draw circle. That is what it takes. Uh, X position and Y position, radius of the circle, and the color of the circle. One will be red, one will be blue. And yeah, let's write vector 2 first and second. These are the two circles. And yeah, we can say first circle will start at both of them will start at the middle of the screen in widthwise, and one would be in the upper half and the other would be in the lower half. And the first thing here would be the width. So we can say that is screen width divided by 2. Draw circle V2, there is a function, I guess. Yeah, and draw circle V, which takes in vector V2. First is X, which is the width, right? So that is cool. And then the second would be screen height. Okay, width, spelling of width is wrong. Substitute width. And the second thing, why is there a error? Floating point, clang tidy, shit, clang tidy is telling us something. Result of integer division used in floating point 2.0. And height divided by 3.0 f. And the second one would start at the same width by 2.0 f, and the height would be, yeah, 2 into screen height divided by 3.0 f. That is nice. While uh, window should close while the window is not closing. While the window, let's just first begin drawing. uh, Draw a circle with a vector. First circle and radius, let's pause, and radius is 20. Radius and color red, and here second, and the color will be blue. And drawing, that is nice. And then here close window, and that is cool. That should work. Okay, yes, that does work. We do see two circles, and let's make this red one move with the arrow keys, and the blue one will move with the mouse position. That would be nice. Hello, I changed my mind. Shell to bash. Okay, there is a typo. Yes, I fixed that. My bad. Hello. Today we are doing this. So yes, there is a problem with the main game. Shit, I cannot just access my terminal. Normally, I have to enter this 7,800 minus 140 minus 156, 7,700, 7,644, 7,644. That might actually be wrong. Shit, but I think that is correct. Okay, shit, that is correct. Okay. Yes, there is a problem with the main game. Game of life dot slash my game, and this is the problem. When I move my mouse too quickly, these cells in the middle are not getting updated as live cells because there is a on a separate thread there is a function which is fetching the current location of the mouse, but that function is not updating very quickly. That function is only updating like at 60 frames per second. But if I want to get the mouse position in frame in the middle of rendering 2 frames, then I do not get resolution. Either I get the position of the cursor at the last frame or from the next frame. So that is bad, and I'm missing these cells which I do not want to miss. So someone suggested, like on shit, everything got messed up. Someone suggested on the Raylib Discord that since I'm getting the last point and the current point, there is a thing which is called differential digital analyzer, which is the standard thing to do, and no amount of polling. Even if I were to use, yesterday we did use direct calls to the operating system, and still this problem persisted. We were not getting enough resolution. So what we can do, since I get the last position of the cursor and the new position of the cursor, we can draw a line, and all the cells, this and this which are on that line, we will color them, and eh, we will have to figure out how to do that. And this thing is called digital differential analyzer. Yeah, and this is the standard practice shit. That is slope. Y2 minus y1 upon x2 minus x1. That is slope. Yeah, we will apply this algorithm. That is cool. Shit, they even have C++ code literally in C++. That is nice. And shit, everything got messed up. Sure, that was the problem. And yes, so before applying this algorithm in the actual game of life game, we will write a simple program here where we have two balls, and we will create a line between them at least so that we can show it on the screen for some experimentation purposes. And I want one of the balls to move with the arrow keys and the other one to move with the mouse. So let's add that functionality. That would be cool. Nope, I don't think right now is the right time. I don't want to take the context just yet. So it makes alive all the cells between last and first. Yes, but what if the mouse movement was curved? That is the point. Since mouse movement is updating 60 frames per second, like 60 times a second, so the amount of difference would be like almost, yeah, the line between the points is almost a straight line, right? The same thing that happens in calculus. So I think that is why this is called differential. So yeah, we won't be getting this as the first point and then this as the second point. We will be getting like points which are very close to each other. So we can treat them as a straight point. So that I think is cool, to track position of the mouse on the window and make them live. Nope, nope. No, we cannot do that because yesterday we did use direct system call instead of relying on the Raylib library to get the current mouse position, and even that was not fast enough. right? We were getting cells missing in the middle. And shit, if you look at Raylib, at this Excalibur, look at this. There is nothing missing in the middle. So Raylib, this Excalibur is doing some crazy stuff behind the back, and I guess it is also using digital differential and library. We can also check. Excalibur uses digital differential and a library. Shit. Okay, they don't know like specifically, but in computer graphics, the DD algorithm is a raster line drawing method. Given two endpoints, you incrementally choose the next pixel by adding a fixed increment based on the slope each this. Okay, it is mostly relevant for low-level pixel drawing routines on bitmaps. It is one of many line drawing primitives. Others including, okay, some other algorithm, Bressenham algorithm. Excel is a high-level whiteboard tool. Yes, the code is available as open source. Shit, Excel is open source, but I did not locate a reference to the repository to DDA. Okay, so it does not use DDA in such modern vector canvas. Line drawing is typically handled by browsers Canvas API, which itself uses the browser graphics engine's own algorithms or vector primitives SVG path rather than manually using a classic DDA conversion on each line. Okay, so something similar. It is, yeah, the main point is it is Excalibur is not polling again and again for the cursor position. It is using Canvas API and the browser is handling everything. Current code misses a lot of points. Yes, that is what we are trying to fix here. Yes, that is bad. Okay, let's first add this get mouse position and second equals get mouse position and the if key is okay key is key is key down and that is if up key is down, if up key is pressed, then we will increase second on first dot y minus if is key key not up but down. If we press the down key, then y position will decrease. That makes sense. And if we press the left key, then x will decrease, x plus plus. And if we press the right key, then x will increase. And I think that is cool. Okay, shit. Okay. There is this. Begin drawing. Clear background. Make the background black. And yes. Okay. So yes, using arrow keys, I can move the red wall, and using my mouse, I can move this. And let's also hide the mouse. Hide cursor. Yeah. Shit. That is pretty cool. And the, shit. Yes, this can go outside. Let's fix that. This can go outside the red wall. So we will fix this, and we'll say after this, if first dot y smaller than 0, smaller than radius by 2, then first dot y equals screen width, which is no screen height plus is screen height plus radius by 2. Point zero f. Cool. And we'll do the same thing here if down key is pressed and we go like out the bottom of the screen, we will go back at the top. First dot y greater than screen height plus radius divided by 2.0 f. Then first dot y equals will come from the top, radius divided by 2.0. Okay, and yes, after this, if we go like too much on the left, first dot x is smaller than radius divided by 2.0 f. Then we will come from the right, which would be screen width plus radius divided by 2.0. Okay, and if you go too much to the right, first dot x, if this thing is greater than screen width, yep, screen width plus shit, yeah, screen width plus radius divided by 2.0. If that is the case, then first dot x would become equal to, we'll come back from the leftmost part already, radius divided by 2.0. Right, and yes, that is working. That is working. Cool. Okay, I guess the FPS might be a bit too much. And yeah, shit, the FPS was too much. And 60 FPS is too slow. 120, so the speed should be double. It is double and is still very small. Okay, that is good enough speed. That is good enough speed. And look at this. When the circle goes more than half, only then does it come out the other way. And shit, yeah, yeah, only then does it come out the other way. So that is kind of cool. And doesn't track mouse position and 60 fps. It will be done by Raylib. Yes, it is done by Raylib, and Raylib is not very precise with the mouse positions. It is not updating the mouse position fast enough, and this is not a Raylib limitation. Even after using direct operating system calls for getting the mouse position, the yeah polling is not good enough for getting everything. So we have to use some imagination and draw lines between the positions. We checked race results. Max came. Shit, no, no. I do not watch. I only watch the memes. Yeah, I only watch F1 memes. Yes, we can make the snake game. Shit, we can make the snake game. We can actually make it like right now. If we, they kind of make it right now like this. No, making a line. Shit, that is something. And yes. Huh. Hmm. What is that thing? Why is this like flickering? That is crazy. Yeah, clear background, and now we have these two dots or circles moving. Now we have to create a line, do some maths, and we will create a line between the two. And let's see, there must be a line function in Raylib. Draw line, should start position, end position, start x, end x. We can use vector, should we can direct from first to second and make the line white. Draw a line with a vector. Shit, we already have a line. Shit. Ah, okay, we can draw the line directly. Already have a line function. Okay, that is kind of nice. This actually looks kind of good. Yeah. Okay, let's read the article and we'll have to do some maths in this. Okay, highlights. Okay, I can also start watching highlights. It would be nice instead of just watching the memes. In computer graphics, a digital differential analyzer is hardware or software used for interpolation. Yes, that is the word which was used by a person. In the mathematical field of numerical analysis, interpolation is a type of estimation, a method of finding new delta points based on the range of a discrete set of known data points. Makes sense. Interpolation, which is different from extrapolation. Extrapolation, I think that is a word. Yeah, extrapolation when we like go towards infinity or something. Yes, when we know that line starts from here, ends there, and then where would the line go from there towards the right? So that is extrapolation. And here we are not looking for where the line would be outside the set of the points which are given. We are looking, we are making giving more precision to the lines in between the points that we already know. So okay, that is interpolation of variables over an interval between start and endpoint. DDA is used for rasterization. Okay, rasterization in computer graphics, rasterization or okay, S and Z, that is the only difference between the two words. Rasterization is the task of taking an image described in vector graphics format like SVG shapes and converting it into a raster image. The rast should that is a fish. Should that is a fish. The rasterized image may then be displayed on the computer display. Okay, that makes sense. So, okay, if we have the description, scalable vector graphics. Okay, if we have a description of an image in terms of vectors, like for example, let's say we have a pentagon, and the way that we are storing this pentagon data is not in pixels, like uh, we do not have a two-dimensional grid of pixels, also called texture, which has this data that this pixel right here should be of this color and stuff like that. We have point in space, like a vector here, two-dimensional vector, and we are seeing this one is connected to another vector which is here, and also to this one, and this, and this. And when we have this vector data, we want to represent this as an image. So we want to know which pixels will have what color in the final PNG or whatever the image format is in that. For that, that process is called rasterization. Okay, okay, that is nice. Triangles and polygons, shit. Okay, polygons like pentagon. They can be extended to non-linear functions such as perspective, correct, texture mapping. Non-linear functions. So, okay, the functions which are defining a relation between vectors can be linear, like the ones they said, triangles and polygons. But rasterization can also be extended to non-linear functions, like perspective, correct, texture mapping. Shit, that is cool. That is cool. Like we can have different points in the same pentagon, and we can say that these are connected through a function like this, which whose curve is like this, and this is what we will have. Shit, that is actually cool. That's like actually cool. And yes, screen is not hidden. That is cool. That is cool. That is cool. Rasterization with linear or non-linear functions, and perspective correct texture mapping. This is just okay. Perspective correct texturing accounts for the vertices positions in three-dimensional space, in 3D space, rather than simply interpolating coordinates in 2D space. Hmm. Okay, that is, I guess, okay. Quadratic curves and traversing vertices. Okay, so there is rasterization. That makes sense. To convert something from vector description into pixels in its simplest form for linear cases such as lines. That is what we want. We want lines. The DDA algorithm interpolates values in interval by computing for each xi equation this. Xi equation this, where m is the slope of the line, and we can get m using this. Okay, shit. Okay, so they are saying since we know the starting point and the ending point, we can choose a little distance, which like let's call it dx, and we will using this as starting and ending point, we can get the slope of the line which is passing through them. Okay, cool. And then starting from our starting point, we will move in the direction of the dx in the ending point, starting point, by dx amount. And wherever we land, the cell at that location in our like in context of our game of life, that cell would we would light up that cell. Shit, is that not too much work? That is okay because like how much can we move? And we can reduce the dx distance to be very small. Right, we can use the dx distance to be small so that we are not skipping over cells. I guess one tenth of the cell size. One tenth of the cell size would be good enough. And we have m, that is nice. Okay, let's without reading the next performance and anything, let's implement this thing. And first, we will implement this in our toy game here. And how can we do this? We'll say, okay, so for all the points which are on this line, we will draw a very little circle there, right? We can draw like a very small green circle there. And travel distance, let's keep it 5 for now. And dot const and dot radius, let's say 2 pixels. And yeah, we'll also have another vector called dot. Okay, okay, another vector called dot. And here we have two things, first and then second. Right, let's get their slope. Yeah, let's get their slope, int, or let's use double. Slope would be equal to, shit, it can be negative. It depends on from which circle we are starting our journey. Let's start our journey from the first circle. So dot x minus sec first dot y divided by second dot x minus first dot x. That is cool. We have our slope, and okay, we will draw the line, and after drawing the line, we will start moving in the direction of the slope. We have the slope, we have the starting point, and we need to move some amount, but we have to move on that line, not just in a random direction, right? That makes sense. Ith would be the last one plus one, and okay, that is cool, that is cool. For every movement in for making one step in x direction, we are going slope m amount in the y direction, which does make sense, right? Here we have 2 points, this and this. We moved, let's say, x amount here and y amount here, and y by x is the m, and if we put x equal to 1, we will get distance in y equal to m. That is nice, we can do that. Okay, for or a while loop would be better. While, yeah, we'll say vector, not vector, dot x equal dot equals first. While the dot first is smaller than, what does dot first mean? Dot x is smaller than dot, then second dot x. Okay, so we will update dot x plus equals the delta that we are moving. Let's call this delta. That sounds more professional. And let's make this 2. But shit, 2 might actually be very small because the radius is 2. Let's make the radius 1. delta, and dot dot y would increase by slope amount. And yes, we will draw circle V, take these coordinates, and radius is dot radius, and color, let's say green, no, bronze. Hmm. Hmm. That is not even close. Okay, why that is going way off the mark. That is going way off the mark. That is not even close. Shit. Okay. Yeah, that is not good. That is not good. Our line is bad. You have to increase the precision, and the slope is nice. And also we have to change this while this and dot dot x is dot x is smaller than maximum of first dot x comma second dot x. This dot is has to be within the range, and dot dot x is greater than std minimum of first dot x and second dot x. While that is the case, do this and let's change shape. Okay, that makes sense. Yeah, delta is okay. Delta is completely okay, but you have to increase slope into delta. Okay, that was the mistake. And okay, we don't have the green line at all now. Should it is actually gone. The green line is gone. Let's remove the draw line function, and yeah, the green line is gone. The green line is gone. Yes. Smaller than first dot x and okay, shade equal to, and here also equal to, and yo, let's go. Okay, okay, okay. This is working. That is working. That is actually working. Hmm. So, okay, this is cool. But now the problem is this. Since we are moving in x direction always, we have to change that because here x is not the problem. Here y is the thing that we should move in. And yeah, yeah. But here it is cool. Here it is not cool. And also when the direction is switched, that is also crazy. Okay, so first, we have two things. One is direction, and yes, hello. We are trying to fix our game of life, and the problem is this. My game. When I move my mouse too quickly, I don't get the position of these cells in the middle, and that is not good. That is not good. So to fix that, what we are doing is it is easy not easy. It is what we have. We can get the starting position of the mouse and ending position of the mouse, and we can move a certain distance in direction from one cell to the other point, and we will keep moving in this whole direction step by step, and all the cells which are in between of 2 points, we will color all of them, right? And here right now we are just trying to simulate that, and we have done this this blue dot moves with the cursor, and the red one moves with the arrow keys, so that is nice. And right now this is what we have. We are able to make the line, right? And yes, these green circles, these are circles which are calculated, which are moving from starting from the red dot till the blue dot, and we have to fix that. First is, the problem is, if I change the order, then yeah, then nothing moves. So we can fix that easily. I guess we can just change the starting position here. No, slope is oh, no, slope would not be negative. We'll say absolute value, right? So that higher minus lower, and dot will not be equal to first. Yeah, let's first see. Okay, this is not rust. If first dot x is smaller than second dot x, yeah, if first is on the left, then dot equals first, else dot equals second. That is nice. And okay, absolute value. That is also nice. We are getting the absolute. Ah, this is not the one. That should be absolute. This should be absolute. Let's see. Okay. And yeah, yeah, messed up. Yes, the line is not very cool. Look at this. It is the y-axis is going in the opposite direction, which is not very good. Yes, the y-axis is going in the opposite direction. I guess because of absolute. Yeah, shit, that was because of absolute. Okay, so now we have this line working. It does not matter which one is on the left, which ball is on the left, and which ball is on the right. So that is very cool. Now what we have to do is, when they are in this manner, when most of the precision is on the y-axis, then we should move the y-axis instead of moving the x-axis, if that makes sense, right? That would be cool. Here, moving one step in the x direction now will take us a lot of the distance in the y direction, and that is not very optimal, because we are skipping a lot of things again, which is the problem that we are trying to fix with this. Okay, so how do we see? We can see which distance. Yeah, we can see if absolute is dot x minus dot x greater than absolute first dot y minus second dot y. If there is more distance in the x direction, then we will move the delta in the x direction. Otherwise, we'll move the delta in the y direction. And yeah, but its slope, we would also have to invert the slope. Yeah, in this case, replace this by y and this by x. And since we are, yeah, this is also fine. Or here, instead of, we can remove this, we can remove there, and the while loop comes outside. If there is more distance in the y direction, then we are in the x direction, then we are moving in the x direction. And if there is more distance in the y direction, then we are moving in the y direction. And also we will have to do slopes divided by 2. The reciprocal of slope here, y x and 1.0 floating point. Let's make it double. Floating point divided by slope. Let's see. Okay. Shit. Okay. Uh. Okay. What is this? This is for not working in this arc. Here it is working. Like that. That is cool. Shit. This is working, and we are getting out of this condition. I guess we are moving too much in the y-x direction, and so either x is in the range or the next y direction is in the range. Yeah, either x is in the range or the next y direction is in the range. So either this or the next y direction is in the range. So dot dot y smaller than equal to std maximum of the y direction, first dot y comma second dot y and dot dot y is small greater than equal to the minimum of the two. First dot x comma second dot x. Okay, there are a lot of brackets. Okay, shit. Okay, and this is still not working in this range somehow. But yeah, everything else is pretty cool. It is pretty cool. Shit, I do not want to use arrow keys. Let's change them to WASD gamer keys. That would be nice. Right key, left key. No. To go up, we will use W. No, we will use E. And to go down, we will use B. And to go left, we will use S. And to go right, we will use right. That is like much better. I don't have to move my hand. Okay, there is a range in which this is not functioning well. Yeah, like right here, we don't get the dots. We don't get the dots. Why? 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 Let's read a bit more or read something out of this. In the simplest implementation for linear cases such as lines, the DDA, the digital differential analyzer, digital because I don't know why it is called digital, but differential because we are going into like very points which are very close to each other, and we are s predicting what the line should be, would have been, which connected those close points, right? Algorithms interpolates values in interval by computing for each xi the equations this and this. Yeah. So yeah, in the last x part we are moving one direction to the right, and in the last y part we are moving m points towards the right, which makes sense, where m is the slope of the line. This slope can be expressed in this terms, and shit, that is some latex right there. In fact, two consecutive points lying on the line segment should satisfy this equation. Yes. The DDA method can be implemented using floating point or integer arithmetic. How can it be implemented using integer arithmetic? Because we are dealing with floats, so that should use floating point. The native floating point implementation requires one addition and one rounding operation per interpolated value. Let's increase the radius of the circles by 1 and also decrease the delta, so we will get like something very similar to a line. Let's see. Yeah, so that is a line. That is a line. Yes, and here the line is going away. Here the line is actually going away. And we can do a amazing thing here. If we remove the clear background function, we will get this. And yeah, we are redrawing the whole, yeah, this something. This looks cool, by the way. Okay, mouse. Shit, this is still getting mouse position when the mouse is outside the screen. That is crazy. That is actually crazy. And see, uh, the lines are being calculated for every point except these two random arcs, and this looks like Ben 10's watch. Yeah, shit. These two random arcs, for these two random arcs, I don't know why, we are unable to calculate the points, the line. Hmm, hmm. Okay, and this is kind of like slighted at a wait, yes, it is. Know what that is? Let's read a bit more. The DDA method can be implemented using floating point. The native floating point implementation requires one addition and one rounding operation per interpolated value. One addition and one rounding of value per interpolation. Okay, coordinate x and y, depth, color, component, etc. And output result. Okay, this process is only efficient when an FPU with fast add and rounding operation will be available. What is FPU? Floating point unit. Shit, a little hardware piece, or NPU. Okay, that is nice. I guess modern computers might have FPUs. Hello, building Pac-Man. No, we are not building Pac-Man. We are building Game of Life, and we are trying to solve this problem that when I move the mouse too quickly, I get what the location of the cursor was at earlier point, and then what the location of the cursor is later on. But this whole distance. I don't get anything in this whole distance, and that is not very good. So we are implementing this algorithm called digital differential analyzer to fix this problem, so that even if when we get two random looking points, the starting and the end point, we can see what are the cells that the line which is connecting these 2 points passes through, and that is cool. And right now, here in this uh, game, you could say, yeah, this is just experimentation before adding DDA to the main game. Yeah, this is Benton. Benton, by the way, this looks cool. You can fix this by adding a single line. And now this is good. Yeah, and yes, I have two balls here, red and blue. Red pill, blue pill. Okay, performance. Okay, the fixed point integer operation requires two additions per output cycle, and in case of fractional part overflow, one addition. Well, let's look at the algorithm. A linear DDA starts by calculating the smaller of dy or dx. Yes, okay, yes, okay, yes, that is by mistake what we did. Here we are checking which one is on which dimension, x or y, we have more distance to travel. A linear DDA starts by calculating the smaller of the two, dx or dy, for a unit increment of the other. Uh, okay, if we think carefully about this, we can write this whole thing properly. Okay, so what do we have? Shit, where is the dot thing? Yeah, here. Slope is nice. Slope is nice. Slope is nice. Slope is correct. And then x or y smaller out to the left, whichever one is on the left. Okay. If slope greater than 1, that would mean we have less distance. Shit. Makes shade. Why did we even do this? Here we are checking if there is more distance to travel on the y-axis, then go in the x-axis. Shit, that is like completely wrong. And shit, at some point, yeah, yo, that is messed up. Shit, that is messed up. If slope greater than 1, that means per unit traveling in the x direction, we are moving more in the y direction. Right. Slope. What should be our starting point and what should be our ending point? The points would be in 4 different configurations. Like if we are treating one of the point as the origin, then the other point can be here, 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 or here. Right, in this case, slope would be positive, here negative, here. We need to start from this point, and here also we need to start from this point. Okay, that is what we'll do. Okay, so there are two problems. First is among the 2 points, which one do we choose as the starting point? And then when we have chosen the starting and the ending point, in which direction to make the progress? And the part about which direction to make the progress is fixed. So we have to see, yeah, we have to improve this part where we are finding the starting point. Cool. Cool. Okay. So, yeah, we here and shit, and according to the starting point, we have to change the slope. So, yes, this makes sense. Okay, if this one on the left, then shit, slope equal this thing, right? If we are starting from the first point, and if we are starting from the second point, then slope equals first dot y minus second dot y divided by first dot x minus second dot x, like this. Okay, shit. The same. We still have the same problem. We still have the same problem. Let's make the radius a bit smaller. Yes, that is like actually pretty cool. We're getting quite a bit of precision in here. Yes, we are getting quite a bit of precision in here. And the problem is, why is the line going away in this random direction? And it is not just going away, since we are creating a lot of circles here. Look at this. Okay, this is not visible on the stream, but yeah, now it is. Here in the red circle, we do have a dot, like a few dots, and that is nice. Yes, we do have a dot, and hmm, and this dot is right here. Even now, I mean, this might not be visible on the screen, but yeah, there is a green dot on the red circle. So we are choosing red as our starting point, but then why are we not creating more of these things? Here our red circle first is red. Okay, let's change in the whole line. In the whole file, substitute the name first with red circle everywhere, and also substitute the name second with blue circle on the whole thing. So this is more clear. Okay, so here red would be our starting point because x of red is smaller than this, okay, and our slope would be also pretty cool. Slope is also correct. Y of blue circle minus y of red circle divided by blue circle x minus blue circle y. That is correct. And then I guess we are not in this condition is not getting true quite a bit. This is how much space is in the x direction, and this is how much space is in the y direction. And wait, shit, is this like float? 0.0 f. Was it a like float mistake? No, shit, no, no, no. It is not a float mistake. I thought maybe they are considering we are always getting into this thing when the things are when the x distance and y distance is almost equal. Yes, when it is almost equal, you are getting here. Okay, shit. I guess we can fix this by saying even when they are equal, go in the x direction instead of the y direction. But how would that? Yeah, yeah, still, yeah, nothing. It doesn't work. It doesn't work. And okay, while either the x or the y of the circle is within the correct range, then keep rendering the circle. Then keep rendering the circle. Slope. Ah, shit. Maybe the slope does not have enough precision. This might be a slope mistake. Slope is a double, so it should have enough precision. And although these things are of type vector 2, which has float numbers. And yes, this arc right here, in which we are not seeing the line. Here we have, okay, yes, here x is very small compared to y, right? X is very small compared to y, so the slope is almost infinite, right? Shit. Okay, and so the slope is almost infinite, and that is why we are seeing the problem. Okay, and in the opposite direction, in this direction, yeah, the same problem, because now blue circle is the starting circle and the slope is almost infinite right here, like in when we draw the graph of tan, right? Sine cos tan, yeah. So the slope is almost infinite, and that is very problematic. But yes, so why are we not seeing anything even in this arc here? Here, I guess right now, currently, maybe we are okay. Let's also print, draw text, the location of both the circles, and also the slope. Draw text. What does it take? It takes the text, literally the text, and text would be format, text format, it, text format, and yes, text format, blue circle, x and y, percent d, not d, we'll call it f, f, and then we don't need a new line, and blue circle dot x, comma blue circle dot y. That is nice. Draw this at the x coordinate should be like 20 is nice, and y coordinate 20 is also nice. Font size, let's test, and that would be white. And here do the same thing, but with the red circle, substitute blue with red globally. Cool. And we have to change the y. Let's make this 40. Make this 40, and then we will also print the slope is just one floating point number, and yes, x is same, and the y should be 60. Font size is f. Let's see what do we have, and yes, shit, we do have everything. Let's increase the size. That is a bit too small. That is, yeah, a bit too small. Mhm. Substitute 5 with 8, 10. Let's go. Substitute 5 with, and shit, the font is not bigger. Substitute 10 with 20. Okay, so um, substitute 10 with 20, and with the font size 20. Yes, that does work. That does work. And look at this. The slope is something, and yes, here the slope is getting very, very big. And why is the slope negative? Negative does not make sense. Negative literally does. Okay, shit, that is the problem. The slope is negative. That is the problem. The slope is negative. The slope is negative. The slope should be positive. Shit. Okay, that is the problem. The slope is negative there. Yeah, and here also the slope is negative, but the slope should be positive. Okay, that is the problem. And here, no, negative makes sense. Negative makes sense here. Yeah, negative makes sense because here our origin is not at the bottom left. Our origin is at the top left. So yeah, negative makes sense. No, we building Minecraft. Yes, we building Minecraft. Bro, by the way, I got a really good Minecraft problem. If you haven't solved it, what is it? You cannot solve? You cannot solve it later. You can solve it later, I guess. Let's see how good your mining skills are. Shit. I thought you were solving CF. Not right now. Okay, shit. Good for this slash how do we see the problems? Contest this problem. See Smilo and Minecraft. The boy Smilo is playing Minecraft to prepare for the battle with the dragon. He needs a lot of golden apples. Shit. And for that he requires a lot of gold. Therefore, Smilo goes to mining. The mine is a rectangular grid of size n by m where each cell can be either gold or stone or an empty cell. Okay, empty cell is also something. Smilo can blow up dynamite, and this is two-dimensional. Blow up dynamite in an empty cell. When dynamite explodes an empty cell with coordinates xy, all cells within a square side of 2k plus 1 Okay, one is that, and x in one direction, x in k in one direction, k in the opposite direction. At the center cell, this becomes empty. If the gold ore was located strictly inside this square, not on the boundary, it disappears. However, if the gold ore was on the boundary of this square, Smilo collects that gold. Dynamite can only be detonated inside the mine, but explosion square can extend beyond the mine's boundaries. Determine the maximum amount of gold that Smilo can collect. Okay, sure, that is nice. GG gold. Okay, here he can blow up here, and this would be gathered, and here blow up here or here. Answer would be one. Shit, zero. And here we can get all four, and here answer is zero because two cells. Yeah, k is two, and here one. So we can blow up this thing. We will also blow up this thing. How can we get two, one? Okay, that is nice. I'll do that at some point. Is it okay to solve 1400? As yes, you can like look up how things are at 1400. That is fine. Not stone cell. Ah, that shit. I have to start reading problems correctly. Okay. And here, yes. Yeah, we have slopes. Hmm. Hmm. And this problem happens when a slope becomes smaller than -1. Why? Because we are here looking at slope. Nope, we are not looking at slope. When the slope becomes smaller than -1. Okay, I guess in that case we are moving in the wrong direction. Here, let's also print delta x and delta y. Delta in x, yeah, there is a single value, floating point value x minus x in blue circle minus like the absolute value of this. And yes, we have to increase the y coordinate to 60, and here to 80, and here 100. Shit. And here, okay, delta x, delta y, and circle x with y, and this should be with t. And let's see. Okay, we have delta x. Okay, when the delta switches from x to y. Okay. And yes, I have to go to the washroom. I'll be right back in a minute and we'll continue on this. You can make it in your to-do. Yeah, I will add that question in my to-do list. And you can solve it later. I'm also solving. Yes, I will solve it. I'm live. It's I'm live. I'm back. And yes. So here, yeah, when y becomes greater than x, when we are traveling in x direction. Okay, that is the problem. And when here still we are moving in the x direction. Okay, and but the slope is still negative. Hmm. But the slope is still negative. And our starting point is the red circle. Our slope is shit. Okay. Okay. Here when we are moving in this direction, slope also has to change its direction. No. Since we are calculating the slope correctly, yeah, the sign also has to change, I guess. Let's see, and shit. Okay. Uh, uh, okay, that is kind of better than before, I guess. Shit. Shit. Okay. Uh, okay, that is kind of better than before, I guess. And let's increase the screen size. Um, to 1600. Okay, that is okay. That is cool. Hmm. Y. Okay, X. We are moving correctly in the X direction, but we are not moving correctly in the Y direction here. If is E down EQ, then break, get out of the loop. And if we press Q here, the game stops. That is cool. Okay, we don't have to increase the delta. We might have to decrease depending on where we are. Yeah, so if dot y is smaller, then okay, we don't know the target. We don't know the target. We don't know the target, like where are we moving currently. But we can see it by the slope. Slope will be able to help us. If slope is greater than, if the absolute value of slope is equal to or greater than 1, and this is a x value problem, and this is a y value problem. Okay, shit, yes, this is messed up. We don't always have to make this negative, and we don't always have to just add the delta. That is the problem. I'm asking ChatGPT for help while solving 1400. Like I ask it to not tell me the solution, but ask me questions to walk me through it. Is that okay? I mean, if at the end you are able to reproduce the solution yourself, then that is quite cool, right? If after understanding the problem you are able to write the solution and maybe even explain the solution to someone else, that would be cool, right? But yeah, if if you are unable to solve any of the 1400 rated problems on your own, then I would say like you should solve more easier problems till you are more comfortable with 1400 rated problems. Yep. And okay, we can write the target. Okay, let's write, take a target. With the two, we'll also have a target here, depending on what everything is. Yeah, starting dot is at red and target is blue circle, and here target is red circle. Right, target is blue circle and target is red circle. Okay, so we only have two conditions now. When the second point is here, starting source point is here, target is here, and when the target is here, how do we change the coordinates? And yes, and in both of these conditions, at some point x would be greater than the y distance. So depending on that, we have to change which one we are changing. Yes, but in okay, let's see when we want to change x. When we want to change x and the 2 points are like this, we will increase x by some amount and we will decrease y. Shit. But yes, we have to keep in mind, okay, this is the trippy part, that the origin is here. So this x is right. X is like the thing that we are used to. X is being calculated from left to right. That is, yeah, what we are used to. But y is being calculated like this from top to bottom. And that is kind of crazy. So when we are, so yeah, shit, the y delta is still the same. That is nice. And the x delta is still the same. Yes, and no, no, no. But we are not taking their absolute differences. Yeah. Yeah, we are not taking the absolute differences, so we will do y of this, which is small, minus y of this, so this will come as negative. So whenever we are making some positive moves in the x direction, we will go a negative distance in the y direction, which is okay, which is cool. Yes, which is like exactly what we want. Yes, exactly what we want. And this is when x is smaller than y. But when y is smaller than x, that is when the points are like this. Yeah, this is the second point and this is our starting point. Here we will make a movement in y direction, but do we go like make the movement positively or negatively? We have to make movement negatively. We have to go up, which makes sense. We have to go up. That makes sense. Let's fix that. So yeah, we cannot just blindly add the delta. Yeah, depending on where the target is. If the target x and y both values are greater than the source, x and y, or maybe we can modularize that and check separately. Yeah, if target dot y is greater than uh, dot y, or even like equal to dot y, then we have to do dot y plus equals delta. That makes sense. Else dot y minus equals delta. That makes sense. And here, yeah, shit, the same thing here. Target dot x, if that is greater than equal to dot x, then we will increase in the positive direction. Else dot x minus. Otherwise, minus. We will subtract 1.0 f divided by slope into delta. Okay, okay, this might actually be it. Okay, shit. Uh, this is stuck. Shit, this is actually stuck. And okay, stream is fine. Stream is fine. That is cool. But the game is stuck. The game is actually stuck. CPU usage is, yeah, not very cool. Oh, okay, this is again stuck. Digital differential analyzer. Stuck. Shit. Plus delta, I guess the FPS 250 FPS. 250 FPS. Why did we increase the FPS from 60? Yes, because we wanted the red circle to move quickly. Wait, FPS has no problem here. Shit. Why is this getting stuck? Okay. Uh, uh, the logs. Okay. Texture loaded successfully. Shit, there is no error. Okay, everything seems to be fine here. Info and nope. 0. Division by 0 error. If so, only then do this. Oh, shit, no, man, there is something else. this game is taking more CPU usage than the browser and OBS. That is nice. And this is the only thing that we changed here. Okay, let's uh, keep that fixed. Yeah. Let's say we only changed X, how X is being updated. Okay, so okay, now it is working fine. Now this is working fine. At least this is not getting stuck. That is one thing. And yeah, we have to fix how we are changing the X direction. Yeah. If dot X is greater than or equal to or smaller than or equal to target dot X, then we want our current X to increase, else dot X. So we can do this on a single line actually, and do this multiplied by target dot y greater than equal to dot y. If the target is greater question mark, then multiply by 1, otherwise multiply by -1. And here also multiply by depending on target, we don't need too many brackets. Target dot x, if greater than dot x question mark, then multiply by 1, otherwise multiply by -1. Okay. Okay, at least this is not getting stuck. That is an accomplishment. Here we are moving in the x direction, but we are moving in the wrong direction in x. Why are we moving in the wrong direction in x? Okay. Delta multiplied by, depending on where the target is. Yeah. Target dot x greater than dot x. If that is the case, then add, otherwise subtract. And here also, depending on target dot y, if that is greater than dot y, or even like equal, then yeah, then yeah, add, otherwise subtract. Okay, shit, this is not even loading now. Shit, this is literally not even loading now. That is messed up, but why? Shit, maybe because at the start, these two things are not really initialized and are outside. But we are initializing target and slope right here before ever running this function. Slope could it can also come here. Yeah, yeah, we are not seeing anything. And the only change that we have made is this here and the way that we are updating these two values. Hmm. Shit, okay, and now it is getting stuck. Close and open. Some updates in lazy. Okay. Yo. And okay, and are we going to stuck? Okay, yeah, we are not getting stuck. That is nice. Not very nice. We are getting stuck. Mhm, mhm. And this is the only thing that we are changing. Why would this even get stuck? Is this while loop never ending at some point? I guess shit. This while loop might never be ending at some points. Okay, I think that is why we are getting stuck. While dot x is smaller than or equal to target dot x and dot y is also smaller than equal to target dot y. We should not get at least stuck. Yeah, we are not getting stuck now. That is nice. That is nice. That is very, very nice. Okay, and we can change these functions now. Uh, yeah, multiply by if target dot x is greater than or equal to dot x, the place where we currently are, then we will increment, otherwise we will decrement. That is nice. And here multiply by target dot y, if that is greater than equal to dot y question mark, if that is, then we will increment, otherwise we will decrement. Okay, and shit, okay, still we don't see anything here in this range. Shit, we are not seeing anything in the first and the third quarter. And we are not even seeing a single dot. Yes, we are not even seeing a single dot. Shit. Yes. Yes, yes, because of this, because of this target and source. Okay, shit. We will have target and we will also have source, so we can see. Yeah, we can see if we are still in between of the two. Yes, in terms of x-axis, our Yeah, we are always choosing the source as the one which has the smaller x-axis, and the target x-axis would always be greater than the dot. But in this case, we don't know actually. So dot dot y has to be greater than or equal to minimum of target dot y comma source dot y. Source dot y, and not just that, and this, and uh, dot dot y has to be smaller than or equal to maximum of target dot y comma source dot y. Okay, this might work. This might work, but no, it does not work. Hmm. Red circle coordinates, blue circle coordinates, and the slope is something. We are not moving in the right direction somehow. We're not even drawing a single circle. We can take a little bit of buffer, I guess, plus delta, yeah, plus delta here, plus delta, and yeah, this would like, okay, we cannot take that much buffer. That is like a bit too much of a buffer. Our source would be the one on the left, and our target would be the one on the right. From fixed format, and source is string, and target is string, and 20 from the left, 120 and 20, and right in white color, and comma, and here the first thing would be source equal red circle, if that is true. Or we can just output the coordinates of these two things. Text format, source, %d, or %f, and target also at %f, %f. Yep. And we don't have slope here. We have source dot x comma source dot y, and target dot x comma target dot y, and start from 120 in the y direction. And okay, y is source 0 0. Source is 0 0, which does make sense. We are not up taking source here. Shit. source equals red dot equals source equals red circle, and here source equals red circle, and okay. uh, hmm. Why is the x direction x thing not moving correctly? When we were moving in the x direction, if target x is greater than source x, then we will increment our x, which is correct. Which is correct, but not here. Okay, x is in both the cases going towards left. Here our source x is smaller than our target x. So x should be increasing, but x is not increasing because slope is negative. Slope is negative. Okay, slope is negative. Slope is change in y dash divided by x dash, and yes, and y dash divided by x dash equals m slope, and then y dash would be equal to x dash into m. So that is nice, but if you want x dash, that would be y dash divided by m, which is also nice. Yes, which is also nice. Y dash divided by m, which is something that we are doing here. Uh, Delta divided by slope into, then we are deciding. But shit, yes, 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 there is also the fact that slope of x and y are different because x is measured from left to right, but y is measured from top to bottom. So there is this discrepancy. Yes, instead of multiplying this thing by, let's say float dy equals delta. Well, delta is always positive, so this is nice. We don't have to do anything here. But here, float dy equals slope into delta, and the slope can be negative. Or shit, we can always take the absolute value of this thing here and multiply this by this, and here also we can take the absolute value of these two things getting divided by each other, where yeah, we also have 1 into 1.0 float into this thing, so that this whole thing is a float. Let's see. Let's go. Let's go. Let's go. Okay. Now we are cooking. Now we are cooking. Okay, this is working. This is working. Let's increase the FPS from 60 to 250. Let's go. Yeah, that is good. That is cool. And our implementation is amazing. Cool. Shit. Yes, that's cool. Let's also do something at the middle point. Let's put a white circle at the middle point of this line that we are drawing. Let's see. Let's see. Can we do that? At the middle point, we will be drawing a line. How would we know the middle point? We know the slope and we know the starting point, and we also know the destination point. That is an amazing line. Okay. How can we calculate the middle point? We have source, we have destination. We are moving, we will keep moving, we will keep moving, we will keep moving, and I guess, yes. Okay, this is easy to find. We can just take the middle point here and we can draw a circle at the middle point. Shit, middle point is easy. Middle point is easy here. Um, Middle dot x would be equal to the difference, absolute difference between, yeah, the absolute difference between target dot x minus source dot x. Yes, that is the difference. Difference divided by 2.0 and add this difference to the smaller of the two values. Minimum of target dot x comma source dot x, add this. Yes, that is nice. And middle dot y will do the same thing. Take the minimum of target dot y comma source dot y and add target dot y minus source dot y divided by 2.0. That is nice. And okay, should we also have to draw the circle after getting the coordinates? Yeah, begin drawing. Draw circle with a vector. The position is this, and the radius, let's say, is 5. Color is white. Oh, that is the middle point right there. That is the middle point right there. And let's draw this over our line with the higher radius than this. Yeah, that is cool. That is cool. We do have the middle point. Let's make this so that whenever I press the up arrow, the number of divisions increases. That would be cool. Like initially the number of divisions would be 2, and when I press up arrow, the number of divisions would become 3, and we would have, okay, I cannot show with the mouse. We would have 3 different divisions at the same distance with the same length. Yo, hello, I am first year. Can you Leibniz calculus for what you are working on? Shit, I don't know Leibniz wait, w- why would you say Leibniz calculus? Calculus is calculus. Newton and Leibniz were fighting. This, what I do know is this notation is from Leibniz, so that is cool. He's kind of cool. Leibniz, Leibniz, and Troy Reiner. Troy, Battle of Troy. Okay, we need to increase the number of divisions. We can do that. We can do that. We will have a thing here. Divisions initially equal to 0. And yep, initially equal to 0. And to update the number of divisions, if if key down, key up, if we press the up key, then division plus plus, but we won't make like more than 20 divisions. 20 would be quite a bit. If divisions greater than 20, we make divisions equals 20. And if key down, then division minus minus. And I don't get why would we even need calculus here. I mean, yeah, it is in the name, I guess, digital differential analyzer. But since our function is a normal linear function, we can work with slope. Normal slope checks out. If divisions smaller than 0, smaller than 1, then divisions equals 1. We won't make it smaller than 1. And now here, for the division code, it will come here, right? For int I equals 0, I less than divisions I plus plus. Middle dot x would be equal to, yeah, SVD minimum of source dot x, comma, target dot x, and add to this. Shit, that is easy. Add to this absolute difference of absolute difference of source dot x minus target dot x divided by division. And we can start this at 1. Yes, we can start this at 1. That would be nice. And middle dot y equals SVD minimum of source dot y, comma, target dot y plus absolute difference in source dot x minus dot y minus divided by difference. And these are floats, so this checks out, and then we will draw circle with a vector at middle at this coordinate, and the radius would be let's say 10, and color white. Okay, okay, let's increase the number of divisions. uh, okay, shit, yeah, okay, this is not working. Okay, this does make sense. Let's also write there the number of divisions. Here we will do middle dot x equals minimum of source dot x, comma, target dot x, and middle dot y equals SVD minimum source dot y, comma, target dot y. Right. So here we can just do plus equal. Right. And let's also draw here the number of divisions. Text format, and divisions a single digit, which would be divisions And here we have to write where 20 and 140 comma 20 and 1. Right, okay. Hmm. Okay, shit, because this is at 120 FPS. We are getting a lot of things here. And also, this is messed up. This is messed up. Yes, which does make sense because first of all, let's change this from down to press, and this also from down to pressed, and then for x we want the minimum, and for y, okay, let's say, yeah, for y also we are taking the, for y also we are taking the minimum. Shit, no, we have to take the maximum, and we will keep subtracting from the maximum. That does work. We can increase the number of divisions, we can decrease the number of divisions. That is very nice. That is pretty cool. 20 divisions is the max. Okay, that is actually not very cool. Now the problem is in the, not in the x direction, but in the y direction. In the x direction, we are going correctly. This makes sense. Okay. We cannot do this like independently. If source dot x is smaller than or equal to target dot x. Shit, do we have to do the same logic that we did for the dots there? Wait. Target dot x, then middle equals source, else middle equals target. And yeah, so x we always have to increase, but for y we will have to see. This thing multiplied by, depending on, but we don't know what is the source and what is the target here. Group divided by divisions, yes. X we always have to increase, but y sometimes we will increase and sometimes we will decrease y. Final y equals initially nothing. Here the final y would be, this is very bad practice, target dot y, that is nice, and here final y would be source dot y, that is nice, and here depending on final y we will do some stuff. Multiply this by, if final y is greater than or equal to middle y, Then we need to increase our middle y, so multiply by 1, otherwise multiply by -1. Yeah, that does work. That is cool. This works throughout. We can increase the number of divisions, and yeah, that is cool. And keep increasing, and everything checks out. You can change the number of divisions and everything. That is pretty cool. Okay, that and that is the whole algorithm. Leibniz. Leibniz is crazy. Yes, so let's read the article now. They also have a program for this. Here, we only read this part of the article about what is the basic concept behind this algorithm, and then we read this. Shit, no, we also read a part of this, but all the problems we solved on our own, so that is cool. This just looks very cool. This just looks very cool. Okay, what else can we do? What else can we do? If there are some suggestions, some farmaish from the chat, we will add that to this simple thing that we have. Shit, this looks cool. This looks cool. And it has been just 2 hours, so that is cool. That is cool. And if there is some suggestion, something that we can add to this game, to this very simple game, you can tell in the chat. I guess here we should draw the balls after drawing the text so that the balls are on top of the text. Yeah. So now, yep, the ball is on top of the text. That is nice. And yo, I think you should do some lead code question in the game, something related to the game. Mm, Yeah, we cannot do everything at the same time, right? And your message got retracted somehow. And this is cool. If this goes out of scope, then this wraps back up and starts from the beginning. Like this, like this. That is cool. Yeah. Yo, yes. Right. Because if I like, where does it stop? If right now I were to think, oh shit, I'm not doing lead code, let's do lead code, and then I start doing lead code, and then I would start to think, oh shit, I don't know anything about game development, then I would start doing game development, and then yeah, this will just keep repeating, and then I would think, shit, I don't know the Linux command line, so let's read about Linux command line, or let's read about operating system. This would like not stop. So blue cursor, yes, there is a thing that means if y becomes smaller than radius. Okay, shit, why would I do radius by 2? Radius is already half of the diameter. Yeah, shit. Replace all of this, substitute all, shit, a literal this, and then 2.0 by nothing. And also f. So please. So if this goes to the, that is not very good. This is good on the left, but on the right it is good, but on the left that is not very good. Add a granny behind. Shit. We can do that. Shit, yes, we can do that. I think what we can do is take a picture of a granny, and the granny would keep, shit, yeah, the granny would keep moving towards the white ball or towards the red ball. Let's see. Yeah, that would be like creating a spirit here. Okay, but the radius is somehow wrong. If S, whenever we press S, and X is smaller than negative of radius. Yeah, smaller than negative of radius. Do this, and here make not equal to radius, but negative of the radius. And here also negative, and here also negative. Let's see. Yeah, that is nice. That is good. Granny. Okay. So we will need a picture, like add a granny, and granny eyes keep looking at the one end of this line. Shit, that is nice. That is nice. One end of this line. That is nice. Yes. Yeah, okay. We can simulate that. We can have a bigger circle, two big circles, and inside the big circles, we will have a smaller pupil. And yes, let's say this is the point that the granny needs to look at. So this point, this pupil, we would have a line here, straight lines from the centers, and the pupils would be at this point inside the circle on the line. Hmm. Okay, let's write another file for that in another, yeah. Mm, granny.cpp, and yep, literally from scratch, not granny, Raylib.h. Int main, promised in screen height is 1600, and screen th width is this, and then window window where screen width and screen height, and then the title is Grand Watches, and then while not windows should close, we will start doing stuff. And wait, what? uh, while not windows should close, and we need four circles, vector 2, I1, I2, and pupil 1, pupil 2, and we will also have a circle which is moving, which will be moving with our mouse. So we'll say our, we'll call it target or ball. Yeah, we'll call it ball, and initially ball would be at the center of the thing, at the center. of the screen. Ball equals screen height by 2 and screen width by 2, but I guess we will get error. Yes, we get error because this has to be floating point. Okay, and now yes, let's draw. But also, yes, we have to fix I1 and I2 are fixed, right? Uh, Constant I radius would be, let's say, 80 pixels. We can test and fix it. Constant pupil radius is, let's say, 15 pixels, and then constant ball ball radius, let's say 15 pixels, same as pupil. And what else? Yes, we also have to initialize I1. I1, the x value would be screen width divided by 4.0, and the y value would be same, screen height divided by 4.0. But for I2, the x value would be a bit different. It would be 3.0 multiplied by screen width divided by 4.0, and the screen height, that would be same, 4.0. That is nice. And here begin drawing. Yeah, draw circle V, I1, eye color, and yes, const auto eye. Eye color would be white, and const auto pupil color black, red. Okay, const auto and ball color would be white or blue. The red eyes are watching the blue ball. Okay, that is nice. And the radius would be eye radius and eye color. Draw the second eye and the pupil. At the start, we'll have the pupil at the middle of the eyes. Right, the pupils should be at the middle of the eye. So we'll say pupil 1 equals here. Pupil 1 equals, yeah, the same value as I1. Pupil 1 equals I1 and pupil 2 equals I2. That is 9. And ball. The ball will be initially in the middle of the screen. Cool. Draw a circle V, ball, and ball radius, ball color, and end drawing, and at the end close window, and that is nice. Let's see. Let's see. Okay, we do have the ball in the middle, and but we don't have the pupils. We are drawing pupils with the eye color, which is wrong. That is also wrong because the radius is also I radius. Yes, that is our granny pupils. And watching this, I think we can make this go a bit more up. This is not very cool. I guess we can reduce the height. Height is a bit too much. 12, let's say. Okay, why is this here? Because the first thing is the width, and the second thing is the height. Right, cool. Let's decrease the height a bit more. 200. Decrease. Okay, that is nice. That is nice. That is nice. Let's make the blue ball move with the mouse. That would be nice. Yeah, this one looks pretty cool. Yeah, better than the main granny. You take image of granny from a Android. Android, shit, what is Android? Just search granny, go to the photo selection, and you will see granny, as you will know why I said that. Shit, okay, let me search. Granny photo. Okay, something crazy might come up. Yeah, granny, I've seen that game, but I don't know how we will be able to change the position of the pupil. But this is cool. This is cool. I guess for dramatic purposes, we can also give a red outlining to the circle, to the white circle that we are drawing. But okay, that will come later. But right now, we will change the ball equal get mouse position. Okay. Okay, shit. Yes, I messed up a little bit. Clear background with the color black. And yeah, let's do, yeah, SPS is fine. SPS is fine. Clear background and also hide cursor. Yeah, so this is moving, and now we have to move these pupils with the ball, which is easy to do. We can move, first you will have to move this pupil in the direction of the ball, in the X direction, then in the Y direction, and the same with the other pupil. X and Y. But shit, no, no, no. The direction. We know the absolute distance because we have the radius of the eye, which is this much, and then we also know the radius of the pupil, which is like whatever it is. Then from this, the absolute direction would be, if this is capital R and this radius is small r, then the absolute direction would be, we will move this towards right by R and then back by R. So that would be the absolute direction. We even know the starting position, starting coordinates. We just have to calculate the ending coordinates. And this is the thing. Shit, do we have to take sine and cos? That would be crazy. So that would actually be crazy. We are here. We need to move in some x amount, and we know the slope of this line on which we have to move this x amount. we need to figure out these two things. We know this. We need to figure out these two things. And we do know this angle. That is crazy. That is crazy. We do know this angle. So yes, we will have to take cos and sine, or that is like at least one method for this. So here we'll have, if this is theta, then this would be x sine theta, and this would be x cos theta, I guess, right? Because I forgot, x theta is this distance upon the hypotenuse, and if we take this there, then we will get the height. That is nice. And here cos theta equals base upon hypotenuse, and base would be equal to, yeah, cos theta into x. So that is nice. And theta theta would be sine, and I think there are built-in functions in C++ to do this. And also, if is key down, E Q, then break, end, exit the loop. Let's see. Angle, shade, no, sine, yeah, sine theta. Yeah, the whole value of the sine. Each shade, yes, we can calculate the whole. Since this smaller triangle in which we have to move, this smaller triangle is a part of the bigger triangle. This is the base of the circle. Yeah, base of the eye, and this is the location of the pupil, and the red ball is somewhere here. Yep, we know this, we know this, we need to know this, and we need to know this. So this is similarity or something. You need to get vertical and horizontal position of the blue ball. We know that it is in this ball thing, and so this is why. This is why. Okay, and we know this distance, and we also know this distance. Can we do this without using any trig? Okay, this is trigonometry. Let's call this x, and this is like big D. Yeah, this is called big D, this whole thing. And then we will have, by similarity of triangles, x divided by, let's call this x y dash, and this x dash, this is small distance, and we would have y dash divided by y divided by y dash equals d, big D, divided by x. Yes, by similarity. Yes, 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 by similarity. This would be it, and therefore y dash would be equal to y into x divided by d. Right, and x dash similarly would be shit, okay, we are using x here also. Let's call this small d. This is big D, and we have small d. So we have y dash equals y into small d divided by big D, and x dash equals x into small d divided by big D. Uh, Small d we already know. Yeah, we already know small d. Small d equals big R minus small r, and capital D we can calculate using Mr. Pythagoras's thing. That's the and hypo, we will call it hypo. That would be equal to square root of absolute distance, distance. Shit, but there are two of them. We should write a function. We should write a function which will give us a vector 2 reference. No, this will not give us anything. Void. This function will update pupil. This will take a vector 2 reference of pupil and vector 2 of ball. And let's declare the function at the top so that we can call this later. Update pupil and vector 2 reference and a vector 2. And yes, pupil. Okay, not int. Hypo equals standard square root of absolute difference of ball comma y minus pupil comma y. No, shit. I, not pupil, but I, because that is our uh, middle value. I comma y plus absolute value of ball comma x minus I comma x. Okay, that is nice. And okay, we have the hypotenuse, right? And according to our formula, yes, we have to calculate this y dash, and we know small d, small hypo is what we call him at home. That would be equal to I dot radius. Shit, we don't know the radius of the eye. We do know the radius of the eye. I can bring already up so that they are accessible. Yeah, this would be I radius minus pupil radius. Small hypotenuse I radius minus pupil radius. Yes, that is how much we want to move in any given direction. So we have d, we have this d, and multiply that by the target y. Okay. Okay. So pupil dot y equals ball dot y multiplied by ball dot y multiplied by small I. This is small, this is big. Makes sense. Divided by hypo. And this should not be hype, this should be substitute hype with hypo. And pupil dot x equals ball dot x into small hypo divided by hypo. Okay, that might actually work. Here we will keep updating. update pupil. Yes, the first is pupil 1 and the second is ball. Do the same with pupil 2. Okay, error. Makes sense. Error makes sense because we also want I there. Yes, I1 for pupil 1 and I2 for pupil 2, and we make the same change here with the 2 and yo. Yo, that is exactly what we were looking for. They are looking at the ball. Granny is looking at the ball. Shit, that is wrong. That is wrong. Yeah, we can fix that, but and I will be right back in a minute. I think you will need to get vertical, horizontal. Wait, yes, this was just 10 minutes ago. Vertical, horizontal position of the blue ball. Yes, we have it. Shit, I read it before. And yes, I will be right back in just 1 minute. I have to go to the washroom. And I'm back. This is literally peak. Uh, okay, let's just play with one ball first, then we will start playing with the second ball. Right? That makes sense. Okay, so okay, that is not even remotely close to where we want it. Shit. Okay, first of all, we don't always have to. This hypotenuse. Okay, we have hypotenuse divided by multiplied by small hypotenuse multiplied by the look the dis. Okay, shit. No shit. It's fine. This is too big. Like both of these values are too big somehow. Ball dot x makes sense. No. I, I dot x and I dot y. Back to the formula. Uh, Small hypotenuse into big hypotenuse and y. Shit, this y is the y distance between the two things. Yes, so that would be, and these are in absolute terms. So absolutely, ab absolute power corrupts absolutely. Absolute of I dot y minus ball dot y. And okay, here absolute I dot x minus ball dot x. Okay, cool. And this is kind of better, but they are maintaining the distance. But okay, shit. Why is this red ball bouncing off? Okay, okay. Uh, yes. So we know the pupil's location, which we are updating, or at least trying to update. Absolutely plus 0.0 float. If this is somehow a floating point problem, which it is not. Okay. The problem is here. When we are here, we are moving more than we should be moving. Yeah, we are moving more than we should be moving. That is the problem. And yeah, sometimes we are moving less than what we should be moving. Small hypotenuse is correct. I radius minus pupil radius. And big hypotenuse is also correct. Square root of this square plus this square. Shit. Okay. Power absolute ball dot y minus I dot o. Multiply and here multiply this by absolute of ball dot x minus I dot x. Okay. Okay, so hypotenuse is correct. Small hypotenuse is correct. And this is also correct. Okay, that is like actually correct. That is actually correct. And the only thing that we have to fix is I dot y plus. And here also do the same thing. I dot x plus this value and shit. Okay, now lo and behold. Wait, now we will be playing with both the balls. Here, update pupil 1 and also the second pupil. Yo. Okay, that pupil is going in the wrong direction, but okay, both of them are. Okay, we can fix the direction. We have to fix the direction issue. Yes. Multiply multiply by depending on yes, this is x. If ball dot y is greater than or yeah, if it is greater than I dot y, then add, otherwise subtract. And here also multiply by ball dot x if that is yes greater than I dot x, then multiply by 1, otherwise subtract 1 and shit. Okay, this I is kind that is good. That is Actually pretty cool. Okay, this is mathematically correct. This is literally mathematically correct. This is always pointing to the right thing, and this is also pointing to the right thing, but this is not how human eyes behave. So we have to, maybe we can do something to fix this because this looks very crazy. Even though this line is straight from there till here, this line is straight, but this is not how human eyes move. Hmm. Hmm. Let's make this a little more scary, I guess. What you will do is, after drawing these two circles, you will draw two more circles at the same place with the radius plus one. Or no, here radius plus one and red. How's this? Yeah, there is like a little outlining outside. That is nice. Let's make this two. How about this? And yes, that is a little bit more outlining. That is cool. That is cool. And shit, we totally forgot the main thing why we did this for the game of life. Okay, I can implement that on my own later. But yeah, this is cool. This is pretty cool. Granny following the ball because she has nothing else to do. And this is also cool. Increase the number of divisions, and we have all of these coordinates which make it look like this is a very amazing thing. But yeah, this is cool. And this font is actually pretty cool. Raylib font. Yo, yeah, that is cool. Let's do some stuff with, I don't know, what can we do now? Let's, okay, it has been 2 hours and 57 minutes. That would be quite a bit long. Let's play with some things. Okay, since we have done this thing, okay, to actually put this in the game, I will do that later on my own. I won't do this right now. But yes, thing is, I do understand now how to do this thing. How to, yes, how to do this algorithm. It is called digital differential analyzer. Let's read this. Linear DDA, digital differential analyzer, starts by calculating the smaller of dy and dx for a unit increment of the other. A line is then sampled at intervals in one coordinate, and corresponding integer values near the line path are determined for the other coordinate. That makes sense. Okay, I want to make this a bit more modular. Okay. Our whole logic, which is calculating the line, is right here. This is the whole logic. While, okay, this is for, yeah, this is the whole logic. Dot, this is a part of it. Okay, can we make this modular? What would our function in game of life need when we have two coordinates? When we have two coordinates, yeah, we will be able to go through all the points which are between those two coordinates. Yep, between those two coordinates. And then we'll see if all the cells which are on that coordinate system, we will turn them on, right? Right, so can we I don't think we can just modularize this whole DDA logic and create a function which will take 2 points. Okay, shit, yes, let's say we can create a function which will take 2 points. What would we want that function to return? That we do not want that function to return anything, because if that function were to return something, we would have to store it in some sort of vector or something. But then we will be calling this function like 60 frames, 60 times per second. And for each iteration, for each call of the function, we will be we will be storing all the points which are in the middle of these 2 points. We will be storing all of them in some array or data structure, and that takes memory. And so for 60 times per second, we will be getting more memory and we will be releasing it, getting more memory, releasing it. So I guess instead of making a function out of this, what we can do is we can just write the whole logic where we want this function, where we want these points in the middle, and without storing them, just at the point check what are the cells at the given locations. That would be nice. That would be nice. Let's read a little bit. Considering a line with positive slope if the slope is less than or equal to 1. Line with positive slope if the slope is less than or equal to 1, we sample at unit x, that is dx equals 1. If the slope is 1, if the slope is less than or equal to 1, which means we are moving more in the y direction than we are moving in the x direction. And the thing that is crazy about this all graphics is the coordinate system starts from here. This is the origin. This is 0, 0. So for x direction, everything is normal as we are used to from left to right. But for y direction, instead of saying that for a point here, this is the x distance from the origin, but the y distance is not this. The y distance is this. The origin is at the top. That is how things work in graphic land. Okay. Considering a line with positive slope, if the slope, yes, if we are moving more in the y direction than we are moving in the x direction, then we will move in the x direction by a fixed amount, which they have taken as 1. And then subscript k means the previous iteration. And for the lines which are where we are moving more in x direction per every change in y direction, in them we will move a fixed amount in the y direction, and we'll calculate what the x would be. And so that is the whole algorithm. Shit, we nailed this. And this is another one. Is an algorithm for line rendering. We are rendering our own line. Shit, this is literally what we want. This thing is literally what we want. We have a starting point, and here this cell is not considered in the line. This is, by the way, literally what we want. Yeah, this is literally what we want. And what is this? Bresson, Bressenham, Bressenham. Bressenham's line algorithm is a line drawing algorithm that determines the point of an n-dimensional raster. Raster, we just saw what raster means. Raster is when we have 2 points, when we have uh, definition of a figure in terms of vector, right? Like in a SVG image, we do not have values of pixels. We have vectors, and that SVG data stores and says that the whole size of the grid is something, and then at some location we have a point, and then at some other location we have some other point, and all of these points, and then these 2 points are connected by a single line or something, and these two are connected by a single line, and then these two. So this is a vector data. This is vector data. And then to convert this vector data into an image and figure out where each pixel would be in a like equivalent image, what would be the color of each pixel in the image that we want to make with this data. This process is called rasterization, I guess. Raster. Yes. Shit. In computer graphics and digital photography, a raster image or simply raster is a digital image made up of a rectangular grid of types. Shit, okay, shit, I messed up. I messed up. That was rasterization of lines. Shit. Okay, rasterization of lines. Okay, the process of this is called rasterization, and this image that is formed, that is called raster. Okay, I think that might be correct. Yo, just noticed. This logo was mentioned by ChatGPT. Window screen also have 00. Wait, Windows screen. I don't know. Windows screen. Like whenever we call a API, do a API call, window gives us the cursor for like position of anything that we are asking for from top left. That is crazy. And yes, I don't know why. I'm like very proud of this function, this program. This looks very cool. Look at this. We can, and this thing on the top makes it look like this is like more crazy than it is. This is pretty cool, I guess. And okay, one more thing that I would like to do is this thing is not full screen. Let's do this full screen. Uh, and my naive approach would be, since we have to give the screen height and width beforehand to this init window function here, I saw there is a function which gives us the size, get screen size and width, but this is for the screen, and screen is the thing that is open. So this will initially give us 0 because nothing is opened, and we want the size of the monitor that we are watching this on before calling the init window function. So we will use this, and before that we have to call this get current monitor. This will return a number. That number we will pass in here, get monitor width and get monitor height to get the width and height of the monitor, and that will be our thing. Okay, int mon number equals get monitor, get current monitor. Should have what? Get current monitor, and this would be get monitor height for monitor number this. Even though I only have one monitor, get monitor width for monitor number this. Let's see. And that is full screen. That is full screen. But why are we just there? That is okay. Red ball is messed up. Red ball is messed up. See how screen height, screen width, 00. Hmm. 0, 0, 0, 0. Physical height in inches. Why are we getting 0, 0? Render height. Screen. Get render height. Okay, ChatGPT. Okay, I got to know this when I was doing some project in React to get some Y pixel below. Y pixel below, I have to do some, yeah, height minus Y. Yes, height minus Y. To get its current position. Height minus Y. Okay, so you are doing height minus Y to get the Y coordinate as it would be if the bottom left was the origin. That is nice. And so Raylib has some window thing. I don't know the exact term. Yeah, window thing. Which are you currently in? Shit. Third year. By the way, do you know how to center a div? Shit. No. No. I don't know how to center a div. I do not know how the knight moves. I will have to like watch some tutorial or ask ChatGPT. Shit. That would be crazy. Like, by the way, actually, I forgot how to center a div. I will have to look it up. Like, no kidding. For real, for real. Let's see. Okay. Uh, how to screen height using Raylib, or I think that is not the right question. We have, okay, there is examples. There must be something in here related to the screen. Shit, wait. Shit, yes. Okay, yes, we will have to add this to our game of life. Zoom in, zoom out. That is cool. Zoom in, zoom out. And one to select mouse, zoom, wheel or move, and mouse left button to drag, mouse wheel to zoom. And how do I move this ball? Shit, that is cool. That was actually cool. Okay, we don't have like a joystick or something. Shit. Uh, should we are moving the whole thing? Raylib is cool. Raylib is cool. Reset, mouse wheel to zoom in, zoom out. Raylib is cool. We can fix what the maximum size of our thing would be, like maximum number of grid cells we will have, and then we can just zoom in, zoom out. And also there is a YouTube video by some person whose name I forgot. Game of Thrones, no, Game of Life, big grid. Yes, this one, this video by Javed. I think that is his name. Javed. Should be David or something. Yeah, this is the game. Yeah, this video. And in this video, he has like 2 to the power 64 something space. Using space encoding. Yeah, that would be cool. Just increase. That's cool. I also done CP31 till 1300 and how to revise them. What is your approach? Okay, my approach is to when I'm doing questions for the first time, I give time to the question that I'm doing till I get to a level that I know what I did, and I would only need like I would have to think about it for like 1 to 2 minutes or like 5 to 10 minutes, and I would know what is happening so that you can give time while you are learning so that you don't have to give a lot of time while you are revising. That is my approach, I think. Yeah. And for revision, just do a bit of questions. You will get back into the state. Yes. Yeah. And by revision, yes, I think by revision you mean how to get back into the state mindset of solving questions. Just do a bunch of questions and you will be back in the state. Have anything to do with ray tracing? No. Yes, I mean, yes, Raylib is also, let me show you Raylib. Okay, why is the name Raylib is because this is a library, and Ray is because we have certain someone called Raysan. This person, Raysan, and his name is literally Raysan. That is why it has Ray in the name because his name is Ray. And his actual name, I forgot his actual name. Creator of Raylib. Yeah, it has Ray in the name because the creator has Ray. And yeah, this also would have ray tracing, I suppose. Look at this video, the project's showcase. Yeah, that game perspective is actually crazy. Like, it is literally crazy. And yes, yes, yes. Back to this, back to this. Yes, I was looking at, yeah, ray tracing. Shit, yes, this does have ray tracing. There was this. Yeah, look at this. We can move this. Yep, let's go. This is what we have. And you can like right now check this out. You can go to the website and literally see this on your own. So that is cool. We can put cell lights permanently at places. That is nice. Yeah. Raylib is cool. Raylib is cool. And they have digital clock. That is nice. They have a lot of things. Shit. Bro, that is something I would want. Shit. Chaos. That is cool. That is cool. Yes, I was looking for how to maximize the window. Toggle full screen. I think we can do that. Toggle full screen. Okay, I guess instead of this, we can open this with some minimum height, 1000, and then we will toggle full screen and we will get the length and height of the screen. Yes. After this, we will do init window and toggle full screen, and then screen height equals get screen height and screen width equals get screen width. Okay, shit. That does work. That does work. And yes, we are full screen, and I don't know how to make this like a small screen. Let's write if the if is the rest f shit f is for moving right. If key pressed is T, then toggle full screen, and we would have to change all of these, add all of these placements, which you calculate here. Okay, equals, and everything else is okay, and we have to do something else. That is okay. Let's see. On T, this does become small. That is nice. Let's make the change more dramatic. 600 degrees, 1000 by 1000, and let's make that 800. That was funny. The aspect ratio is not changing. That makes sense. Even though the size of the screen is changing, the aspect ratio is not changing. That makes sense. Okay. That is cool. Yeah, solve more problems. Yes. Why is this here? Can we make this in React, like the light thing and the random swing bar? That is not random, that is chaotic. Chaotic. It is not random. There is a little distinction. It is totally calculable beforehand, but React, I guess we can call an external component in React which renders all of this, and for that there are libraries in React which we can use. React 3 or like 2D JavaScript 2D libraries, or yeah, 2D graphics libraries. 2.js is something. Sorry for that. And where do they have their examples? GitHub. They do not have examples. Pixie.js. Hmm. Hmm. Showcase. Share. That. Okay, share. That. The universe is behind my mouse. That is cool. That is cool. Uh, Showcase. All of these. Adventure time. Okay, shit. This is in pixie.js. You can use pixie.js for this. Shit. That's a file. Okay. I suck at games. Okay. Okay, that is the game. Shit, shit, shit. Piano Planet with mouse. Okay, okay, that is okay. That is enough. Yeah, you can make a game like that. How do I exit? I cannot exit. Yeah. So yes, you can use something like this for your game. UIX is also something. They have Subway Suffers in this library. So this seems like a good library. Pixie.js. HTML creation engine. Create beautiful digital content with the fastest, most flexible 2D WebGL renderer. Yeah, WebGL. That is cool. Yeah. We want we have to attach gravity to the bar. I don't get that. But yeah, this is cool. We have this. Yeah, this is cool. We can increase the number of divisions. This just looks really cool. And yeah, yes, don't know how to exit Vim. And that would be, wait, shit, what happened to my screen? Okay, no, 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 that is fine. My bad. Okay, and that would be the end of today's stream. We have done quite a few things today, and that is nice. So, yep, that would be it for today. And thank you for being here.